Good evening, ma'am. Before we start the session, I kindly invite Dr. Suraj sir to introduce our speaker.
Okay.
So good evening, ma'am. I'm excited to introduce our esteemed speaker, Dr. Geeta Devi, an associate professor in Department of Mechanical and Industrial Engineering at the National University of Science and Technology, College of Engineering. With over 30 years of experience in academia, industry, and research, her current focus is on developing novel nanomaterials for applications in wastewater treatment and corrosion control. She has published over 80 peer-reviewed journals and conference papers, and Dr. Devi has received 18 funded research projects awards from the Ministry of Higher Education, Research and Innovation and the National University. She was honored with the Best Researcher Award for the academic year 2020-2021. She has edited the book titled Environmental Nanotoxicology published by Springer Nature. Currently, Dr. Devi supervises 5 PhD scholars in nanotechnology, chemical engineering, and environmental engineering, and successfully guided 2 PhD graduates. Her students have won several prestigious awards, including Omani Young Water Research Award in 2018, the Innovation and Technology Award at the Oman Petroleum and Energy Show 2022, and the Gulf Petrochemical and Chemical Association Research and Innovation Award in 2019 and 2022. Ma'am serves on the editorial boards of several journals, including Fine Chemical Engineering Journal, Journal of Modern Nanotechnology, American Journal of Nanomaterials, and Current Research in Biopolymers, and is a reviewer for numerous international peer-reviewed journals. With all due respect, we welcome you, ma'am, to this event. Over to you, ma'am.
Thank you, Suraj, for the nice introduction. And thank you once again, all of you. I will share my screen now.
Yeah, ma'am.
Okay. Good evening, one and all. I'm Dr. Geeta. I'm from National University of Science and Technology. My presentation topic is Industrial Effluent Treatment, a technological aspect towards climate change. Before starting my presentation, I would like to give a briefing about our university. A national university was established in the year 2018 by merger of 3 leading professional engineer institutions: Caledonian College of Engineering, Oman Medical College, and College of Pharmacy. And in the year 2022, 2 more colleges has been added to the university, that is College of Advanced Technology and International Maritime College, Oman. Caledonian College of Engineering is currently known as College of Engineering, was the first private engineering college in Oman, established in the year 1996 in academic partnership with the Glasgow Caledonian University, UK. And we have 15 undergraduate programs in medicine, pharmacy, and engineering courses. Apart from that, 8 master's program, and recently we have received ministry approval for starting PhD programs. And coming to the research and innovation at National University, we have 7 core research groups in various research areas, and scientific research is conducted in close cooperation with the local and regional industries and also the research institutions from the regional as well as international partnership. We have attracted so many funded research projects with more than 3.5 million US dollars, and our major funding agency is from Ministry of Higher Education, Research and Innovation, and also Industrial Innovation Center, Middle East Desalination Center, and also local and regional industries. And Center for Research and Innovation has a dedicated research labs. We have two research labs, that is Waste to Energy Research Laboratory and Solar Water Research and Nanotechnology Laboratory, to carry out cutting edge research. And coming to the core research groups at College of Engineering, we have 7 research groups in intelligence maintenance monitoring and instrumentation, sustainable energy conversions, technologies and management, automation, robotics and manufacturing, novel materials and nanotechnology, artificial intelligence and machine learning, water and environmental sustainability, and innovative sustainable materials and structures. And our research is mainly focused on energy and industry, information and communication technology, health and social services, and environmental and biological sciences. We have received 35 awards in the last 5 years at national and international level, with 177 funded research projects. And our publication has 4,000 plus international journal and conference publications, with 1,512 Scopus publications. We have 30 plus active international research collaborations and more than 70 PhDs already supervised. And out of that, the student 70 PhD supervised and 500 student publications are already published, with 360 master dissertation, and we have currently 30 plus patents. And majority of the funding we have received from the industries, that one of the leading chemical industry in Oman is Petroleum Development Oman. And in nanotechnology research core group, as nanotechnology is one of the significant area of research expertise available in National University, with the focus on development of nanostructured materials with the fundamental applications of nano thin films and biomedical and industrial wastewater treatment. We also undertake research in corrosion control in oil industries. Nanotechnology Research Group also provides innovative solutions to industrial problems, mainly in environmental and corrosion areas, by the application of nanotechnology. And coming to the projects and achievements, we have received projects from National University research funding is there, and also industrial research. And apart from that, the major funding is from Ministry of Higher Education, Research and Innovation. Nanotechnology research team has produced 5 PhDs and more than 30 master's dissertations and 40 publications during the last 3 years. And we have received the funded research project recently. We have received a project from ministry. It was worth 20,000 OMR. The project title is Development and Application of Nano Materials for the Corrosion Control of RC Beam Steel Reinforcement. And another project we got it is also 20,000 OMR, but it is for the pharmaceutical applications. We develop nano capsules for anti-corrosive. Good. And also functionalized mesoporous silicon dioxide nanoparticles for the treatment of industrial wastewater treatment. These are our ongoing research projects, and for the past 3 years. And we received some projects from the students' research funding for green hydrogen production waste car batteries and its application in cleaning of paraffin wax deposits from oil pipelines. These are the running projects now. Some of the projects we have already completed. These are the 2019, it's already completed. And our undergraduate students are getting awards from various competitions. Now recently they got the chemical engineering students, they got Outstanding Engineering Young Material Corrosion and Integrity Engineer Award, and that was in September 2024. Also, the student got International Invention and Innovation Award 2023 from Korea. Also Thailand Award for the Best Innovation Award. And the project calcium carbonate nanoparticle as a novel nanomaterial for the effective treatment of grey water for sustainable and circular economy in water management has been featured as one of the top 100 worldwide innovative projects exhibited in Global Grey Show Prototype for Humanity in Dubai. Also, our master student got Innovation and Technology Award in the Petroleum and Energy Show. And other Gulf Petrochemical and Petroleum Association Award and Best Paper Award. And also the faculty members and students participated in United Nations Climate Change Conference. Our Novel Materials and Nanotechnology Research Group has also participated in first Oman Innovation Festival, and also we have partnership with other universities, University of Niswa, German University of Technology, and Sultan Qaboos University. Coming to the research collaboration with external institutions, our major collaboration is with the Ministry of Higher Education, Research and Innovation, University of South Carolina, USA. We have some programs, master's program also with in collaboration with the University of South Carolina, and also our PhD programs. And Sultan Qaboos University, University of Niswa, Middle East Desalination Research Center, National Institute of Technology, Durgapur, Jamia Millia Islamia, New Delhi, Khalifa University, UAE, MG University, Kerala, Puducherry Technological University, India, Covenant University, Nigeria, and University of Malaysia, Pahang. And in the nanotechnology research laboratory, we have state-of-the-art facilities like a total organic carbon inductively coupled plasma emission spectroscopy, X-ray diffractometer, Fourier transform infrared spectroscopy, and potentiostat and galvanostat for the electrochemical workstation. This is used for the corrosion testing, and ultrasonicator, ultrasonic reactor, microcentrifuge, the COD incubator and digester, etc., and many more. So I'm coming to my presentation on the application of nanotechnology in environmental pollution control. So environmental pollution is one of the major issue all over the world, that is increasing global population, and also industrial activities will result in severe environmental pollution. So the contamination of water, and it will be affecting the human health as well as ecosystem. So it is important to find a suitable treatment system to remove the pollutants. So the major challenges in wastewater treatment is the nature of the pollutants. There are complex pollutants, and conventional treatment methods are not effective, and also it will be expensive. And the efficiency and sustainability also low. So nanotechnology offers a solution to address these issues. So in my first I will be starting with the synthesis of nanoparticles and its application in wastewater treatment. So the nanoparticle synthesis, the recent development in the field of nanotechnology offer numerous solutions to treat water, and nanomaterials play a significant role in removing suspended and dissolved solids due to its high surface to volume ratio, as well as the controlling functional properties. So nanoparticle mediated treatment are considered as a promising alternative to traditional water treatment techniques. And we fabricated nano thin films, and also we applied nanoparticles for the wastewater treatment application. It's due to its excellent properties, and nanomaterials have a tremendous attention in recent research. The nanoparticles we have synthesized in our in-house laboratory are silica nanoparticles, calcium carbonate, titanium dioxide, zinc oxide, graphene oxide, and silver nanoparticles. And these nanoparticles are characterized using scanning electron microscopy, energy dispersive X-ray analysis, Fourier transform infrared spectroscopy, X-ray diffractometer, dynamic light scattering, and zeta potential. And these nanoparticles were employed in the treatment of industrial wastewater. We have applied in corrosion inhibition studies and also for the drug delivery, that is the different types of drug encapsulation and release we have done using the nanoparticles. So in this today's presentation, I will be focusing more on the wastewater treatment application. The synthesis of silica nanoparticles. The nanoparticles are synthesized using Stauber's protocol by the reacting tetraethyl orthosilicate, ethanol, and ammonium hydroxide. So the reaction is shown here. So the reaction is carried out by mixing 50 ml of ethanol, 10 ml of ammonium hydroxide with a rapid stirring for 20 minutes. And this was followed by 0.4 ml of tetraethyl orthosilicate, and the reaction was carried out up to 8 hours. After 8 hours, the resulting nanoparticle suspension was centrifuged to 10,000 rpm for 10 minutes and then dried to 120 degrees Celsius to make a fine powder. The dried form of the powder was used for the characterization and analysis. The major characterization and analysis are carried out using scanning electron microscopy. Scanning electron microscopy was used to find the surface morphology of the synthesized nanoparticles, and the purity and composition analysis was done using energy dispersive X-ray analysis. Functional groups present on the surface of nanoparticle was done using Fourier transform infrared spectroscopy, and the average particle size was determined using dynamic light scattering. Surface charge was determined using zeta potential measurement, and also the phase identification was carried out using X-ray diffractometer. And these nanoparticles were employed in the treatment of oily wastewater treatment and as well as textile industry wastewater. So the treatment efficiency was assessed using by measuring chemical oxygen demand, total dissolved solids, total suspended solids, dissolved oxygen, and turbidity. This is the characterization result, that is the scanning electron microscopy image shows the particles are spherical in shape and the particles are well formed with scattered distribution. And we could see that the particles are almost spherical in shape. Also, we have analyzed the purity of the synthesized nanoparticles using energy dispersive X-ray analysis, which is aligned with the scanning electron microscopy. And it shows silica is 27% and oxygen 54.5%, confirming the purity of the nanoparticles. And the XRD analysis shows one single peak represents the nanoparticles are amorphous in nature. And the Fourier transform infrared spectroscopy shown here, it has got many representative peaks which represents the different functional groups present on the surface of nanoparticle. This is the dynamic light scattering DLS analysis. You can see that one single peak represents the particles are almost the same size range, that is 300 to 350 nanometer, and the average size is almost 340 nanometer, which confirms the size of the nanoparticle. This is the zeta potential measurement of the nanoparticles. And these nanoparticles are employed in the treatment of wastewater. So water pollution is one of the major environmental concern, and it results in the depletion of groundwater resources. The major reason for the water pollution is rapid industrialization, population increase, and also urbanization, which lead to huge demand for fresh water and which resulted in generation of enormous quantity of wastewater. And various industrial activities produce huge quantity of contaminated water which are discharged into the environment, leading to severe environmental pollution. The industrial wastewater treatment in Oman, there are two leading industries which produce huge quantities of wastewater, and also it is highly polluted organic discharge. That is, textile industry contributes to 48.78% of the Oman's GDP, and also the production capacity of refineries in Oman stands 22,000 barrels per day. It was estimated that for every 1 barrel of oil production, almost 8 barrels of water is discharged as a wastewater. So it is very important to protect our groundwater resources from industrial pollutants. This flow sheet shows the schematic representation of conventional methods of treatment of wastewater, that is physical treatment, chemical treatment, and biological treatment. Physical treatment mainly gravity separation, membrane separation, etc. And chemical treatment methods is oxidation, reduction, precipitation, and biological treatment mainly focus on microorganisms based degradation. And the conventional methods has got a certain lot of shortcomings. In the one is cost of maintenance cost will be high, and disposal of discharge of large quantity of sludge, and also consumption of large quantities of chemicals with high solid loading. So the effectiveness of removing pollutants like metals, organic and inorganic compounds are very less. So it is essential to go for a new technology to reduce the pollutant level and before being discharged into the atmosphere. So that there are certain new techniques available: advanced membrane technology, advanced oxidation process, and also application of novel nanomaterials, membranes, nanocomposites, etc. are being investigated to remove the discharge of pollutants. And composition of wastewater normally differs from one industry to another based on the type of processes which is involved. Also, there is a good scope for solar treated water, because the intensity of solar radiation is high in Oman, and due to the abundance in the available resource from sunlight, we can go for photocatalysis, and also nanomaterials are used as a photocatalyst. It possesses excellent photocatalytic property and have very high surface to volume ratio. And majority of Oman's economy is from oil and gas sector and also textile industry. As I mentioned, these two industries are discharging highly polluted water. These two industries consume huge quantities of water during its manufacturing process in each stages of operation, and almost the same quantity of water it is discharging into the environment. So refinery wastewater contains also huge quantity of toxic organic constituents such as hydrocarbons, phenols and heavy metals, and it has got high COD values. Sorry. So these silica nanoparticles we have tried with the treatment of textile industry wastewater. So batch experimental was conducted by varying the processing parameters of effluent solution. pH was varied from acidic to alkaline range. Contact time was varied. Dosage of nanoparticles and stirring speed was varied. After the treatment, the efficiency of the wastewater treatment was monitored using the measuring COD, TDS, TSS, dissolved oxygen, turbidity and conductivity, and the percentage of removal efficiency was calculated using this equation. We have tried the bare silica nanoparticles for the treatment of textile industry wastewater, as well as the surface of the silica nanoparticle was modified, that is surface functionalization was done using the nano coating over the surface of nanoparticle with low molecular weight chitosan. And this is the experimental outcome, that is when we increase the pH from acidic to alkaline range. These are the results we obtained. And also the stirring time was varied. This is a result for stirring speed and also the dosage of nanoparticles, and the optimization of these parameters has been done, and the optimum processing conditions was obtained as pH is 2 and 4 hours of contact time, 2 gram per liter of dosage and 360 rpm stirring speed. And this is the characterization result of the nanoparticle after treatment process. So after treatment, there will be the particles, that is pollutants will be adsorbed on the surface of the nanoparticles. These are the scanning electron microscopy image of the nanoparticle after treatment. You can see that in the first case, the nanoparticles are completely destructed. Previously, it was in spherical shape, and it is now, after treatment, it is completely destructed, and most of the pollutants are adsorbed on the surface, and it become little dark. And the second figure represents, this is also scanning electron microscopy of the coated nanoparticles, but it retained its spherical shape, and here also the efficiency was very high. And the outcome of the result was published in Indian Chemical Engineer Journal in 2018, Synthesis, Characterization and Application of Nanoparticles in Wastewater Treatment. The second type of nanoparticle we have synthesized in-house is calcium carbonate. It's synthesized by homogenization and precipitation technique by reacting sodium carbonate and calcium chloride 1:1 ratio, and this is the reaction involved in the production of calcium carbonate. It was conducted by reacting 0.1 molar sodium carbonate and 0.1 molar calcium chloride, and it was conducted for 20 minutes. Within 20 minutes we could able to get the calcium carbonate and then centrifuged at 10,000 rpm and followed by drying to 80 degrees Celsius and made into fine powder. This is the scanning electron image of the calcium carbonate nanoparticles, and it is at a magnification of 2500. We can see that the particles are well formed, and it is high yield, shows the nanoparticles are synthesized, and also the purity of the nanoparticles was done using energy dispersive X-ray analysis. It is seen that oxygen is 52.6%, carbon 25.7% and calcium is 18.2%. This also shows the high purity of the nanoparticle. This is a X-ray diffractometer and diffraction analysis. It is seen that the diffraction peaks, various peaks represents the particles are in crystalline in nature. That multiple peaks represent the particles are crystalline in nature. This is the functional group present in the surface of nanoparticle, that is FTIR spectroscopy gives the various functional groups present on the surface of nanoparticle, and characterization using zeta potential shows the surface charge of the nanoparticles. And this calcium carbonate and silica nanoparticles were employed in the reduction of chemical oxygen demand from refinery effluent. We have collected the refinery wastewater from the Petroleum Development Oman, a leading oil company in Oman. These are the characteristics of the refinery wastewater which we collected from PDO. And here the processing conditions were varied from pH varied from 2 to 10, contact time was varied from 20 to 120 minutes, and dosage of nanoparticle from 0.1 to 0.6, and the stirring speed of 25 to 150. And first we started with using calcium carbonate, and we could see that as pH increases, the percentage reduction in COD increases, and maximum reduction occurred at a pH of 8. And here the contact time was varied, and this optimum pH was kept for the next experiments, and here the time was varied from 20 to 120, and we could see that 90 minutes is getting higher COD removal. This is the batch adsorption using stirring time, speed was varied, and also the dosage was varied, and the optimum processing conditions were obtained at a pH of 8, a stirring speed of 100 rpm, and mixing time 90 minutes, and a dosage of 0.4 in case of calcium carbonate. We have compared the efficiency of silica nanoparticles by conducting the same experiment, that is pH was varied and stirring time, stirring speed, and dosage, and here the optimum processing conditions were obtained as pH is 4, stirring speed of 125 rpm, mixing time of 90 minutes, and a dosage of 0.5. And this project was published in Journal of Indian Chemical Society, synthesis and application of silica and calcium carbonate nanoparticles in the reduction of organics from refinery wastewater. This was undergraduate student projects. And this project got International Invention and Innovation Award in 2023 from Korea, West International Invention and Innovation Award from National Research Council of Thailand, also Gulf Petrochemical and Chemical Association Innovation Award for the best innovative project and contribution to the scientific community. We have also tried the application of calcium carbonate in wastewater treatment, how wastewater can be, the pollutants from wastewater can be removed by using calcium carbonate. We used grey water. So the grey water was collected from a kitchen sink. This is the characteristics of grey water. It is seen that COD is 1811, and here the batch experimental studies are conducted by varying the parameters. And this is the experimental outcome of the nanoparticles, calcium carbonate nanoparticles in grey water treatment. And we could see that after treatment, the COD reduction was 235, from 1811 to 235. There is a considerable reduction in other parameters also. So after treatment, we have taken the deposited, that solid particles, and we could see that the particles are completely filled with the pollutants, and it becomes very dark. That shows the success in the treatment. And the optimized conditions are pH is 8, stirring speed of 100 rpm, and stirring time 75 minutes, and dosage of 0.5. So in conclusion, the treated grey water can be utilized for toilet flushing, house cleaning, and garden irrigation. And we have used this one for this treated water for agricultural purpose, especially for the irrigation. And we could see that the best result was obtained at 5 to 7 pH. And the remaining solid materials we have used as additive in the cement concrete as an admixture in building material. That shows, that means zero wastage and save our environment. And this can be implemented as a low cost treatment technique for anywhere it can be applied. And also this project is directly related to satisfies the goals and targets of United Nations Sustainable Development Goal, that is goal number 6, clean water and sanitation for all. Also it supports Oman Vision 2040, that is clean water for all. And this project also got some awards, that is it has published in an IOP conference series, Scopus publication, and also Springer Journal publication. And this project was selected as one of the top 100 impactful and innovative projects displayed in the Global Grade Show, that is called the Prototype for Humanity in Dubai during 26 to 3rd November 2023. And also this project was selected as the best innovative project, and it was exhibited in the first Oman Innovation Festival held in February 2024. And it is presented in various conferences at Sultan Qaboos University, Niswa University, Sohar University, University of Technology and Applied Science, and German University of Technology. Next type of nanoparticles we have synthesized is titanium dioxide, and it is synthesized by salt gel method using titanium isopropoxide, ethanol and distilled water. Reaction time was kept at 8 hours with a pH of 2. The reaction was carried out at room temperature. This is the scanning electron image, microscopy image of the nanoparticles at a magnification of 5000, and it is seen that the nanoparticles are formed, but it is in the clustered form, that is very thick distribution. And the energy dispositive X-ray analysis shows the titanium is 50.6% and 47.4% of oxygen. That shows the highest purity of the nanoparticle. This different peaks represents the XRD analysis, that is, it shows it is crystalline in nature. This is the FTIR spectroscopic image, and the particle size analysis, it shows that the particles, average particle size is almost 0 to 5 nanometer, which is one of the good quality of the synthesis method. And we have employed these nanoparticles in the preparation of nano thin films. So we have prepared chitosan titanium dioxide nano thin films, and it was applied for the degradation of methylene blue dye. So for preparing the nano thin films, the coating solution was prepared by dissolving, mixing 2 grams of chitosan and 50 ml of 1% acetic acid, and the stirring was continued for 2 hours, and titanium dioxide was added. 0.3 grams of titanium dioxide was slowly added and followed by stirring for 24 hours till it get a required consistency, and that solution was used for the deposition of nanomaterials on glass slides. So we have used the thin film making is by dip coating method, that is one glass slide is dipped into this coating solution. So the fabricated nano thin films were employed in the treatment of simulated wastewater containing methylene blue. This coated glass substrates were placed vertically in the dye solution, which is to be treated, and along the sides of the beaker and stirred continuously, and it is exposed to sunlight. And the processing conditions maintained are solution pH was varied, contact time, initial methylene blue concentration, and number of deposition layers. This is the image of the chitosan titanium dioxide thin films with the different compositions. We could see that in the first slide the coating is not proper, that is we have used 0.5 grams of chitosan and 0.3 grams of titanium dioxide. In the second case, the amount of chitosan has increased, and third one is 2 grams of chitosan. In all these three cases, amount of titanium dioxide was fixed as 0.3 grams. And this film was characterized using, that means to see the surface morphology. So we have characterized using scanning electron microscopy, and it is seen that the particles and also polymer was coated uniformly, and that is completely covered on the surface of glass plate. This is the FTIR spectra of chitosan titanium dioxide thin films, and this is the degradation results of the nano thin films. by varying the number of layers, also pH, contact time, initial dye concentration, and also the deposition layers. And we could see the optimum values are effluent solution pH is 6, contact time of 120 minutes, dye concentration of 0.6 milligram per liter, and number of layers, deposition layers is 12. And this study shows that chitosan titanium dioxide multilayer thin film is an excellent adsorption capacity, and also it require very small quantity of the materials, that is it is coated over the surface by nano layers, so the quantity requirement is very less. And this same slide can be repeatedly used for further degradation stages, so it will be very effective compared to the other type of conventional type of treatment methods, especially in other type of conventional treatment methods will be discharging large quantity of solid waste. So here there is not much solids deposition. This was published in International Journal of Environmental and Analytical Chemistry, that was published in 2021. Next, we have synthesized the zinc oxide nanoparticle, that is salt gel method. We using zinc acetate dihydrate, sodium hydroxide, and the reaction time was maintained at 24 hours at a pH of 2. The scanning electron microscopy image of zinc oxide nanoparticles shows the particles are well formed, and also it is very thick with a larger quantity of the materials. It shows high yield also. And the analysis purity is tested using EDS spectroscopic analysis, that is zinc oxide, zinc is 62.5%, oxygen is 21.6, carbon 12.9, etc. This is the FTIR spectra of zinc oxide nanoparticles and XRD spectra of zinc oxide nanoparticles. This is the nanoparticles size. It is almost 40 to 65 or 70 nanometer, that is less than 100 nanometer only. And the surface morphology of the coated thin film, it is observed through scanning electron microscopy. It is seen that the coating is well formed, and also we investigated the surface topology, how the surface looks like for in the atomic level. We can see that this is two-dimensional figure and the other one is three-dimensional image using atomic force microscopy. And we have used this nano coating for refinery wastewater. The refinery wastewater was collected from the PDO outlet. And effect of variation of pH is shows here, and the stirring time. Here also the number of deposition layers are also varied, and we have investigated the percentage reduction in parameters. And this is the very thick surface, shows the particles are well deposited on the surface of the thin film, and also it is very thick. Okay, for in conclusion, this chitosan zinc oxide nano thin films were developed by this method of coating is by dip coating method, and it was used for the refinery wastewater, and also zinc oxide nanoparticles of size 660 nanometer were successfully synthesized using modified salt gel method. And the processing conditions, our optimum processing conditions were obtained at pH of 8, contact time of 60 minutes, and 10 number of layers of chitosan zinc oxide with a stirring speed of 100 rpm. And this shows that the nano composite thin film is an excellent pollutant. It shows excellent pollutant removal from the refinery wastewater. This offers a safe and sustainable water management system aligning with the goals and targets of United Nations Sustainable Development Goals, that is 2030 agenda of UNSDG, and also the Oman Vision 2040. This is the outcome. It was published in Indian Journal of Chemical Technology. It was published recently. And also we have synthesized silver nanoparticles from mesquite tree leaf extract. Mesquite tree is a common tree in Oman, and this is very dangerous tree. So we have utilized this tree extract for the synthesis of silver nanoparticles, and the methodology employed is biosynthesis using silver nitrate and silver nitrate and the extract. It was taken in the ratio 1:8, and the reaction was carried out for 36 hours, and it is centrifuged at 6000 rpm for 10 minutes to get the product. And the product was dried, and it was used for the characterization, and the characterization methods employed are SCM, energy dispositive X-ray analysis, DLS, FTIR, XRD, and zeta potential. This is the image of the synthesis steps, that is fresh mesquite tree leaves, and it is converted into the extract, and that extract was mixed with the silver nitrate solution, and the synthesized nanoparticles were subjected to surface morphology study using scanning electron microscopy, and this shows the energy dispositive X-ray analysis. And also the characterization was done using FTIR spectroscopy, and also particle size also ranges from 20 to 40, and the XRD pattern shows it is crystalline in nature. And this also we have applied in the removal of COD, TDS, TSS, dissolved oxygen and turbidity that is present in the oily wastewater, and the pH was varied from 2 to 9. Mixing duration was 30 to 150 minutes, and the amount was varied from 0.1 to 0.8 gram with an agitation speed of 25 rpm to 100 rpm. These are the characterization results. And in conclusion, biosynthesis of silver nanoparticles are successfully synthesized from mesquite tree, and this was applied in the oily wastewater treatment, and the optimum conditions were obtained at pH of 5, agitation speed of 100, contact time of 90 minutes, and nanoparticle dosage of 0.7 gram per liter. This also as per the all wastewater treatment is with United Nations Sustainable Development Goal. And this innovative cutting edge research will be transforming the waste material, that is especially is a dangerous mesquite tree, into value added product, and it can be effectively utilized in the removal of pollutants from oily wastewater. This was published in a conference, Web of Science conference recently. These are our featured publications from our lab, nanotechnology research laboratories in the past 3 years. These are the publications, and this is with end of the session, and I take this opportunity to thank the organizers and also Amal Jyoti College of Engineering, especially Professor David K. Daniel. He was always supporting us, and he was our external examiner for a long time. Thank you, sir, for your all supports. And also National University of Science and Technology for providing us opportunity to work on the industry-based and also nanotechnology research by giving facilities, and also our funding agencies, Ministry of Higher Education, Research and Innovation, National University Faculty Research Grant, National University Student Research Grant, and Graduate Research Grant and URG from Moheri. Thank you. Thank you once again.
Thank
And
you, ma'am.
also thank you. We are also looking for collaboration with all any institutions. We do have collaboration with various institutions. We welcome all for collaboration in research as well as faculty exchange program, or also joint publications. That all we can look for that. Thank you. Any queries?
Thank you, ma'am. Now we'll be opening the Q&A session. Participants can either unmute yourselves or use the chat box for asking the questions. Ma'am, we have a question in the chat box. The Josna has asked, how was chitosan membranes after dye treatment disposed? And how is the waste handling done after treatment?
Yes, actually, this is based chitosan. We are developing the nanomembranes, chitosan and nanoparticles. So that one we will be using 4 or 5 cycles of treatment. After that, we will be doing that cleaning process. There will be a mild acid cleaning will be there, so that we can reuse that again. Also, backwashing facility also there. Initially, when we are using the first 10 layers of coating, then we got some 80% of removal efficiency. Then later, when we are using the same slides, means slides in the sense that deposited slides. So it was showing 76, 74% like that. So that means it is still we can use it for. We have tried in our laboratory 4 times. So the efficiency was very good. The major advantage of this is actually we can limit the solid waste disposal problem. And we have a reusability, as well as the amount of the material which we consume is very small. So it is economically feasible. And cleaning facility is also done after 4 layers of coating, 4 deposition cycles. Then we are doing the treatment. After that, we can clean it and reuse it using the dip solution.
Thank you, ma'am. Are there any more questions from the participant side?
I know that everyone will be tired at the end of the day. All energy will be drained out.
Thank you very much, ma'am. So we'll move on to the conclusion of the session. I kindly invite Dr. Suraj Sirajan for delivering the vote of thanks.
Thank you, ma'am. On behalf of Department of Chemical Engineering, Amaljodi College of Engineering, I am happy to extend our heartfelt gratitude to our esteemed speaker, Dr. Geeta Devi, for sharing their invaluable insights with us today, and had a detailed discussion had done in the presentation on the synthesis of different nanoparticles and experimental works with application to industrial effluents. Thank you so much, ma'am, for sharing your knowledge with us today. With a token of gratitude, the Department of Chemical Engineering, Amaljodi College of Engineering, sharing a virtual memento with you, ma'am.
Thank you, Suraj, for your all support, and I'm accepting your Thank you. Thank you so much. I hope we will have a good collaboration later.
Yeah, ma'am.
Thank you.
Thank you.
Thank you.
Thank you
Thank you.
so
Thank
much.
you,
Thank
one
you
and
so
all.
much.
Thank you. Goodbye.
Once again, thank you all for joining us today on AICTE ATAL FDP program. We'll be meeting each other tomorrow at 6 o'clock for the fifth day of the FDP training. Now, a feedback form will be shared in the chat box. Kindly make sure to fill it before you leave the meeting. Thank you once again for joining all. We'll meet again tomorrow and we'll continue with engaging sessions on climate change. Thank you.